Okay, AP Calc kids, this is going to be on the two comparison tests, series tests, the direct comparison test and the limit comparison test. Now, you could technically use the limit comparison test all the time. However, the direct comparison test is sometimes more convenient, and you really should know both. So let's start with the direct comparison test. Now you can just call this DCT if you wish. So the direct comparison test, I primarily tend to use it with P series or geometric. When I'm comparing a P series or a geometric, all right? So here it goes. If you have some series, some positive series, that means a sub n greater than or equal to 0, and you have another positive series, b sub n, the rules are, if the series, remember this bottom index doesn't matter, n equals a constant to infinity, of b sub n converges, and a sub n is less than b sub n, then the series a sub n converges by DCT. So smaller than a known convergent converges. That's what this means in layman's terms. Smaller than a known convergent converges. All right. 2, if the series a sub n equals a constant to infinity, diverges, and 0 is less than or equal to a sub n less than or equal to b sub n. So this means b sub n is greater, then the series b sub n equals 1 to infinity diverges as well. Okay, so in layman's terms, what this means is larger than a known divergent diverges. Okay, so you cannot use this test if you have larger than a known convergent. It's inconclusive. Or smaller than a known divergent. Okay, the test is inconclusive. DCT test. Direct comparison test. Inconclusive. All right, so now we're going to try this test. So let's look at a couple of examples. All right, let's say you have the series n equals 1 to infinity. Again, the 1 doesn't matter. 1 over 2 to the n plus 3. Okay? So, we're going to compare this. What does this look similar to? So, compare to the series 1 over 2 to the n. Okay, what kind of a series is this? This is a geometric series, right? And what do we know about it? We know that r is equal to the absolute value of 1/2, right? Which is equal to 1/2, which is less than 1. So this series 1 over 2n converges by geometric series test. Okay, then you have to show the comparison since 1 over 2 to the n plus 3 is less than 1 over 2 to the n. Remember, a larger denominator is a smaller number. Okay? So since that is true, the series n equals 1 to infinity of 1 over 2 to the n plus 3 converges by direct comparison test. Okay, that's how it works. All right, let's look at another one. Let's compare to a p-series. Previous page and write down when n is the power, it's a geometric series. You have to know that difference, okay? That's extremely important, okay? So let's say we have the series n equals 3 to infinity of 1 over the square root of n minus 4. So we're going to compare this to the series 1 over the square root of n. Okay, so we know that this is the same as 1 over n to the half power. So in this case, your n is the base. Remember, when n is the base, it's a p-series. Go to the next slide. So here, all right, this series is a p-series. So we have p equals 1/2, which is less than or equal to 1. Okay, therefore, this series, 1 over square root of n, from n equals 3 to infinity, diverges by the p-series test. Then you do your comparison. So you would say 1 over the square root of n minus 4 is greater than 1 over the square root of n, because a smaller denominator is a larger number. So since this is true, the series n equals 3 to infinity of 1 over the square root of n minus 4 diverges by the direct comparison test. All right, so that's the direct comparison test. We'll be doing more of that in class. Let's look at the comparison test. So a lot of people do prefer the limit comparison test. I prefer to use direct comparison test first, and then if that's inconclusive, then I use limit comparison test. So I'm a big fan of direct comparison test. Limit comparison test, here we go. If you have two positive series, that's what this means, and the limit of their ratio, now it doesn't matter which one goes in the numerator, the limit of their ratio equals some constant number, or we could do it the reverse way. Like I said, it doesn't make a difference. B sub n over A sub n equals L, where L is both finite and positive, then here's what we would have. The two series A sub n and B sub n either both converge or both diverge. So the reason some people prefer this test is because if you have larger than a known convergent, you can use it. And if you have smaller than a known divergent, you can use it. So in the last test, you wouldn't be able to use it. All right, so here we go. And also when you don't know the direct comparison too well, as far as which one's less, this one also becomes easier. Okay, example. And I'm just going to do one. Let's say we have the series n equals 1, all right, to infinity. And we'll say we have 1 over 5n squared minus 3n plus 2, okay? So we're going to compare this. What are we going to compare this to? You see this n squared? That means we're going to compare it to 1 over n squared. Okay, so what does the series 1 over n squared do? Now, n is the base. So that means it's a p series, right? So p is greater than 1. Therefore, this series converges by p series test. Whatever you're comparing to, you have to say what that series does and why it does it. So now we're going to get the limit as n goes to infinity. Okay, it doesn't matter which one we put in the numerator. So I will put 1 over 5n squared minus 3n plus 3 divided by 1 over n squared. Now, you guys know that when you divide, you multiply by the reciprocal, right? So when we multiply by the reciprocal, this is what we end up with. Now, you know how growth rate works as you go to infinity? So these don't matter. So you look at the coefficient, which is 1/5. Okay, so because this is a finite positive number, okay, so because the limit of a sub n over b sub n as n approaches infinity is a positive finite number, this series, okay, we'll call this b sub n, call this a sub n. The series b sub n converges by the limit comparison test. Okay, we'll continue this in class. This is a good foundation though. And you can go back and keep watching the other videos if it helps you to review the tests, because these tests really add up. We only have one more left. Thank you guys.